Question number 1. Firstly, we have to understand what is leap year. Mathematically, a leap year is a year that is evenly divisible by 4, except for years that are divisible by 100 but not by 400. Then the year is a leap year. First, we declare three integer variables a, b, and I. We then prompt the user to enter the starting and ending years of the range they want to check for leap years. Using the scanf function, we read in the values of a and b entered by the user. We then use a for loop to iterate over each year in the range from a to b. For each year, we check if it is a leap year using the following logic. A year is a leap year if it is divisible by 4 but not divisible by 100. However, if a year is divisible by 100, it is not a leap year, unless it is also divisible by 400. If either of these conditions is true, we print a message indicating that the current year is a leap year. Once the loop is complete, the program terminates. I hope this explanation helps you understand the code. Question number 2. What is even number? If a number is exactly divisible by 2, then it is even number, otherwise it is odd number. The main function is the entry point of the program. It declares three integer variables, a, b and I, to hold the user's input for the start and end of the range. The printf function is used to display a prompt to the user to enter the start of the range. The scanf function reads the user's input and stores it in the start variable. Similarly, it prompts the user to enter the end of the range, and the scanf function stores the user's input in the end variable. The printf function is used to display a message to indicate that even numbers in the range are going to be printed. The for loop iterates through the range from start to end, and the if statement checks whether the current number I is even or not. If I is even, the printf function is used to print out I. While terminates, the program returns 0. Save the file. Program runs successfully. And print even number between 1 and 100 are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on. Question number 3. Program to print prime number in a given range. Firstly, we have to understand. What is prime number? A prime number is a number that is only divisible by 1 and itself. In C code, we can check if a number is prime using a loop to check if the number is divisible by any integer between 2 and the square root of the number itself, then it is prime, otherwise not. We start by including the stdio.h and math.h library, which contains the necessary functions for input-output operations. We define a function called isPrime, that takes an integer argument number and returns an integer value. This function checks if the number is a prime number or not. It does this by iterating through all the numbers from 2 to square root of number and checking if any of them divide number evenly, i.e., with no remainder, then number is not a prime number and the function returns 0. Otherwise, number is a prime number and the function returns 1. In the main function, we declare three integer variables, a, b and I. We prompt the user to enter the start and end of the range using the printf and scanf functions. We then print a message to the console to let the user know that we will be printing the prime numbers between start and end. We use a for loop to iterate through all the numbers in the range from start to end. For each number, we call the isPrime function to check if it is a prime number. If the number is a prime number, we print it to the console using the printf function. After the loop finishes, we return 0 to indicate successful completion of the program. Question number 4. Print Armstrong number in a given range. Firstly, we have to understand, what is Armstrong number? An Armstrong number, also known as narcissistic number, is a number that is equal to the sum of its own digits, each raised to the power of the total number of digits in the number. For example, 153 total digits are 3 and 1 raised to the power 3 plus 5 and raised to the power 3 plus 13 and raised to the power 3 equals 153. Hence, it is an Armstrong number. The code starts with including two header files, stdio.h and math.h. The stdio.h header file contains functions for input and output, and math.h contains mathematical functions. Next, the code defines a function called isArmstrong, which takes an integer as input and returns an integer value, 1 or 0, based on whether the input number is an Armstrong number or not. The function first declares and initializes some variables, I, original number, sum, and digit. The variable, original number, is used to make a copy of the input number. The while loop is used to count the number of digits in the input number, which is stored in the variable, digit. After that, the variable, n, is reset to the original input number, and a for loop is used to calculate the sum of the cubes of the digits of the number. The for loop calculates the sum for each digit of n. The percent operator is used to get the last digit of n, which is then raised to the power of digit using the pow function. The sum is updated with each iteration of the loop, and the last digit of n is removed by dividing n by 10. If sum is equal to original number, then the number is an Armstrong number, and the function returns 1. Otherwise, the function returns 0. Main function of the program. It first prompts the user to enter a range of numbers. The values of a and b are stored using the scanf function. The program then prints a message indicating that it is going to output the Armstrong numbers between a and b. The for loop is used to iterate through each number in the range, and isArmstrong is called for each number. If isArmstrong returns true, then the number is an Armstrong number, and it is printed to the console. The program returns 0 at the end of the main function. Program runs successfully and prints Armstrong number between 1 and 1000 or 1, 2, 3, 4, 5, 6, 7, 8, 9, 153, 370, 407. Question number 5. Print strong number in a given range. Firstly, we have to understand, what is a strong number? A strong number is a special type of number in mathematics. It is also known as a Krishnamurti number. A strong number is defined as a number whose sum of factorials of each of its digits is equal to the number itself. For example, 145 is a strong number because 1 factorial plus 4 factorial plus 5 factorial equals 1 plus 24 plus 120 is equal to 145. Note that 1 factorial and 0 factorial are equal to 1 by definition. Thus, 1 is also considered as a strong number. Hashtag include stdio.h includes the standard input-output library in the program. This is a recursive function named fact, which calculates the factorial of a given number n. It returns 1 if the input number is 0 or 1, otherwise it calculates the factorial of n by calling itself recursively with n, 1 and multiplying the result with n. This function named isStrong takes an integer input n and returns 1 if it is a strong number, otherwise it returns 0. The function first declares two integer variables, originalnum and sum, with initial values of n and 0, respectively. It then enters a loop that continues until n becomes 0. In each iteration, the function adds the factorial of the last digit of n, obtained by n%10, to the variable, sum, and updates n to the quotient of n/10, to remove the last digit. After the loop ends, if the final value of sum is equal to the original value of n, the function returns 1, indicating that n is a strong number, otherwise it returns 0. The main function of the program. The function declares three integer variables, a, b, and I. It then prompts the user to enter the range of numbers to check for strong numbers. The two integers entered by the user are stored in a and b using the scan function. The function then prints a message indicating the range of numbers that will be checked for strong numbers. Next, the function enters a loop that runs from a to b, inclusive. In each iteration, it checks if the current number, I, is a strong number by calling the isStrong function. If it is a strong number, the number is printed to the console, separated by a comma and a space. Finally, the main function returns 0, indicating that the program executed successfully. And print the strong number between 1 and 1000 or 1, 2, and 145.